Hello, everybody. My name is Paulo Guillen. I'm a solutions architect for Micron Technology. And this presentation is automating TPC-C tests with HammerdDB and PowerShell. It is recorded, but I will be online answering any questions. So let's see the agenda today. So we will have a brief overview, and then we'll do a demo. And we just do a code deep dive, all the PowerShell command libs that I'm using. And let's do the overview. So why running your own benchmark? There are already benchmarks made by different vendors. So, the reason that I do it is to verify things that are configured correctly in your environment. So it's very useful to know if you're reaching limits or not. And then you can choose what's the most cost-effective solution. So what is TPC? It stands for Transaction Processing Performance Council. It has two P's, but for some reason we only use one, so it's TPC. So this organization provides standards for database benchmarking. And why HammerdDB? Because it is a software that is a leading open source that is used by many other platforms like MySQL and Postgres and Oracle and SQL Server and so on. And it runs the TPC-C and the TPC-H, which are derived from the TPC standards. So the TPC-C is the OLTP benchmark, and the TPC-H is the OLAP. It measures the NOPM, that stands for number of orders per minute, and it are run by parallel virtual users. And why PowerShell? Because it is a glue language, so we can combine all the software or commands from HammerdDB, SQL Server, performance counters, and Excel that we can, I'll show you in the demo how to do that. So your next slide is my demo architecture. So I'm using Azure to run the demo, but it runs also on premise. So I have two VMs. One VM is called Demo VM, which is a standard D4. It has 4 CPUs, 16 GB memory, and runs on Windows 2019. And then I have another VM, which is the SQL VM that for starters, I only have two virtual CPUs and 16 GB memory. And it's a 2019 developer edition of Windows 2019, and it has a drive, an F drive for data, and a G drive for log, and a D for TempDB. And so these two machines need to talk to each other, so they're in a domain. So I'm using Active Directory domain services, and my domain is pacopico.com. So they're in a virtual network. And so the best practice is to run the software on a different machine than your SQL Server, right? Your SQL Server is for just a database. So all the software I'm going to show you runs from the demo VM. And I'll show you next. So the PowerShell script, as I mentioned before, it will run from the demo VM. And what you will do, there are basically 4 major processes. So the first one is it will create a TPC-C database. Once the database is created on the SQL VM, then I'll run the virtual users, which are the users that run the workload, and it will insert data to the TPC-C database. And then while it's running, I will collect the perform counters from the machine for the virtual CPU and the disk. And once I collect it, then I'll create an Excel chart so we can so So next slide. So the demo VM configuration. So it has PowerShell 5 that comes with Windows. We can use PowerShell 7 too, but at least we need 5. ODBC driver 17 for SQL Server that comes with SSMS. So I have SSMS installed, but if you don't have, you have to get it from somewhere else. Also install HammerdDB 4.5 for Windows. You can download it from the HammerdDB website. Then you need to add to the environment variable, to the path environment variable, the HammerdDB directory. And then copy from, see, all these scripts are available in the conference materials. So you copy the HammerdDBPS.tcl to the C program files, HammerdDB. So the TCL is the language that HammerdDB uses for scripting. So I have a script that accepts parameters and run the commands. So that's the TCL file. And then I create a module called HammerdDPS module that also is on the conference materials. You just copy it to this folder, HammerdDBPS. And that module I use PowerShell Crescendo. So the PowerShell Crescendo module allows you to create like a wrapper of executables. So I create a wrapper of the HammerdDB executable that accepts parameters and behaves just like a commandlet. And also you can parse the output, and the output becomes a PowerShell object. So once it's a PowerShell object, we can use all the PowerShell ecosystems with all the other modules. So the other module that we're going to use is the import Excel. So just install the module. And finally, the other module is SQL Server, to interact with the SQL Server and configure databases and so on. My next slide. So now we are on the demo. And I'll show you the demo plan. So normally when we make changes, we do one at a time. So first we run the tproxy workload and we collect the baseline. If we make a change, and then we do another tproxy workload to collect the change in performance and so on. So we change one variable and then run the workload again, so we can see if there is a change in performance or not. So if I go to, so I already RDP to my demo VM. And as I mentioned, I can show you, so HammerdDB is already installed. You can see it's in program files, HammerdDB 4.5. And I already copied the TCL file from the conference materials. And also I have this HammerdDBPS module that I wrote with PowerShell Crescendo, which is a wrapper to the HammerdDB executable. And then I have the TPC-C folder, which has all the scripts to run that are also in the conference materials. And I have PowerShell. I have the modules installed. You can see on, for example, users, my name, documents, Windows PowerShell. There. Oh, I think the Windows modules are in program file, or the Windows PowerShell modules are here. So I have import Excel, and then I have SQL Server, and the other ones come with Windows PowerShell. As I mentioned, also we need to update the environment variables. So I already have on the path. So I already added HammerdDB. So now to run PowerShell, you can use PowerShell, the PowerShell 5 editor, or you can use Visual Studio Code. So in this case, I'm using Visual Studio Code. So I open the location, right? So this is my module, and then you just go to the build folder, and there is the demo file that we're going to use, which is this one. So the first thing that we need to do is to create the database. So here I'm going to load the modules that are for HammerdDB. And then I'm going to create the TPC-C database on the SQL VM. So I'm going to invoke this commandlet that is using the PowerShell Crescendo module, and that is a wrapper. So at the end, when I do the deep dive on the code, I'll explain the internals of this commandlet. But for now, I'll just create a database, and it has a concept of warehouses. So the virtual users that are going to be generating the load are going to be creating orders, and each virtual user, we use a warehouse that has areas and inventory and so on. But we can see the database. Once I create a database, we can see all the tables and see how it's structured. So right now, I'm just going to run it. So it's going to create the database. So I have Management Studio here. So this is the SQL VM. So currently, there is no databases. So I'm going to run this to create a database. So if I run it, so you start running, you will call my script. Now start running. So it's going to create the database, and it's going to create the tables, and it's going to insert data to the tables. So right now it's running. So if I do a refresh on the databases, so I had a TPC, and then it should have the tables here. So it has warehouse, districts, items, new orders, and so on. So each virtual user that logins to create a workload is insert the data here. And I have a link also later on the PowerPoint slide that it will cover the model or the data models for this. So I can submit it while it is running, so I can show it. So at the end, so it's over here. So we can see on the reference links, we can click on the workload for the database. Is a TPC-C, the one that we're using in the demo. So you can see the relationship between the tables. So for each warehouse, there is like a 100K stock items. They have districts, 10 districts per warehouse, 3,000 customers per district, and the number of orders and the load that it's going to generate is explained over here that you can read later. But for now, it is creating the database here. So these build virtual users are the ones that are inserting the data to the database. So right now, we're not testing the workload, we're just creating the database used for run the workload. It takes about 20 minutes. So right now, I'm using 20 warehouses. So I have a development subscription. If I'm in a prod subscription, I can use maybe 100 warehouses. The more warehouse that you have, the more parallelism that you can have. Parallel inserts. But in this case, I'm just using 20 since I have a development subscription and just building this database with only 10 users. But if you have a bigger machine, you can have more warehouses with more virtual users. So again, it takes about 20 minutes to build the database. So I'm gonna pause the recording, and then we'll see when it finishes. Okay, so now the database creation already completed. So you can see the output. This is the same output that HammerdDB will have when you're running. So I'm just scrolling back so you can see each virtual user that's building the database, what he's doing. So it tells you how many orders and warehouses and districts. It's populating all the tables on the database, so we can see all these tables that have rows. We can check here, and we can see all the customers and so on. So all this data that is using is random data. So one of the advantages of using HammerdDB is that you don't need to worry about security. All the data and all the customer data here is randomly generated, so it's nothing real. You can see the streets, the city, nothing that will compromise someone. So you can see the district tables and so on. So all these random data that the other users, when we do the test, are going to use this and create orders and so on. So here are some. So that's the way you can see how the table is populated, and that the data that you generated is all random. And these are the warehouses. So when I run the test, in this case, I only, you remember I selected only 20 warehouses. So there are 20 rows. So each row is a warehouse. And I usually do one warehouse per virtual user. So I'm going to use a maximum of 20. But in production, for example, I'll use 100. So 100 users and 100 warehouses. Go back to my code here. So the next thing I'm going to do is, by default, HammerdDB will create the database in full recovery mode, but I'll change it to simple, and also increase the size to 10 gig and 1 gig log, so it doesn't auto grow all the time. So I'm going to run this part of the code. So I'm using invoke SQL command. So this commandlet comes with a SQL Server module, where you can, similar to SQL CMDB, you can run all type of queries for SQL Server. This, it's the current size is the same. So okay, you don't need to worry about it. We can see. So now, we're going to collect performance counters. So the performance counters for CPU or processor is this one. And then for the disk, so we have the F drive, the G drive. This is the G, the D, and the F. So we know F is data, and then the first set, right? So is this second transfer is the equivalent to this latency. The transfers per second is IOPS, and the bytes per second is the throughput. So we typically, measure those three to see if there is an I/O bottleneck. And I use these performance counters on the VM, so I can use the same code for on-prem or for cloud and for any vendor, because I can use the Azure also monitoring, but it's just specific for Azure. But this script can run to, other like AWS or GCP or on-prem. So I'm just using the counters from the VM, not from the portal. So I need to pass those. So I'm gonna run this part. All right, so initialize the variable. So now that's where we start doing the benchmark. So I'm gonna do the baseline first. The way it is configured right now. So right now is the machine is a E2 series, and the disk is P4. So my computer name and the instance name is the same. Duration of the test is 1 minute per virtual user. So the virtual users are the ones that are going to do the job, but you can pass an array. So it's 5, 10, 15, and 20. So each one of those will last 1 minute. So in total, the test will last about 4 minutes. And again, if you are in a production subscription, you can run more virtual users, like a 50, 70, 90, 100. And also you can put duration, maybe 10 minutes, 20 minutes. But I am in a development subscription, so I don't want to saturate it. So, I'm gonna run this, which will start the benchmark test. So run it. And then this is the same output that you will have if you're running HammerdDB. So right now is doing the first set, 5 virtual users. It's going to run for 1 minute. And when it finish, it will do the 10 users running for 1 minute. When it finish, it will do 15 users for 1 minute, and then 20 users for 1 minute. So it takes 4 minutes. So I'm gonna pause the recording, and we'll come back. Okay, so it completed now. So before we run another test, so we have this, the baseline, and then we can, for example, do an Excel spreadsheet. So this is the one that does Excel spreadsheet. So right now I put the results on a variable called result1, and we can see here, for each user. So in this case, we have, for 5 virtual users, we have the number of orders per minute was 10,000, and the respective performance counters for the disk. Remember, D is 10 dB, so it's 0 because I'm not using 10 dB. But F is data, G is log, and then the total CPU, so it's 20%. And then for 10 virtual users, now, for example, CPU goes to 27, 15. We can see, the CPU is 30, but also, the transactions per second and the orders per minute will increase a little bit. So that's the way you can, one way to see it is through the results, but another way is to visualize it. So right now we only run one test, so I'm gonna assign the first result to the results variable. And then, so this is a hash table to tell Excel how to pivot the information, because all these right now are rows. So we want to transform those into columns. So I want to pivot the rows, so the virtual users, and the pivot columns is the test name. In this case, they're all the same test name. But when we combine the results, we'll see the difference, right? So all they'll have the same. And then when I pivot, it will be the sum of the values. So I can run this part over here is to tell me the name of the columns. So right now there are rows, but if I run this, that will tell me, the node properties are the columns. So now I'm going to loop through each column to form this. So I'm going to run all this. And then if I print table, so now has this format on the hash table, but I can also go to a key, for example, that transactions per minute. So which are these values that I'm passing here. So for each column, I'm just telling how to pivot, which is the parameter for the next command or commandlet, which is export Excel. So I'm going to delete the file if it already exists in my PC or on my VM. And then I pipe the results to this commandlet. And I'm passing the pivot table definition. So I'm going to run all this together. And that's it. So I generated the Excel spreadsheet for my baseline, right? For my first test. And we can see the output on temp. So this is the TPC-C file. But I don't have Excel installed on this VM. But even though I don't have it installed, the module, the export Excel commandlet, it will generate the Excel spreadsheet for you. And again, because I don't have that Excel installed in my PC, I can upload it to Office 365 and upload it. It's uploading to OneDrive. And when it finishes, it will have the spreadsheet, right? So remember, this is the same test name right now, but for each virtual user. So instead of rows, now there are columns on, you want to see the latency or so F is data, so it's the IOPS, right? You see increasing, but it will also generate the pivot charts because that's what I told them. So let's see the number of orders per minute. So with 5 users, I only have around 10,000. With 10 users, I can get to 14,000. With 15, 16,000, almost 16, and with 20, so almost I'm already reaching the peak in between 15 and 20. We can see also, let's see, the CPU. So we are getting about 35% use CPU on, remember this is an E2, so there are 2 virtual CPUs on a P4 disk. What other interesting? Oh, so F, the IOPS. So we're almost reaching the 3,000 limit for this disk. But yeah, so this is my baseline. So that's how I started. I started with 2 virtual CPUs with a P4 disk, and I generated a chart so we can have an idea of how it works. So I go back to my script, and I go back to, oops. So we already this test was our baseline. So the next test is, for example, increasing the virtual CPU. So from 2, what happens if I increase to 4 and run the same test? So let me go to the Azure portal, which is over here. So I already have the SQL VM over here. So let's change the size. So the current size, as I mentioned, is a E2, 4. No, this one is wrong. So let me refresh. It's a 2 CPU. For some reason, showing a different one. But if I go to the size over here, so this is the V5 series. So currently, it's a E2 with 2 virtual CPU. But for some reason here in the overview, oh, now it refreshes. Now it's showing 2 CPUs, probably because I was testing earlier. So now I have this, and now I'm going to change the size. So go back to here. So it's a E size B5. So the current size is E2. I'm going to change it to a 4 CPU. So I'm going to change it to E4. And I do resize. So it will take a few minutes, but I'm going to pause the recording. All right, so now I completed. So we can go back to our script to run the other test. So now we're going to put the results on a variable called result2. All right, so let's run this. And again, it's going to take about 4 minutes. So I'm gonna pause the recording again. All right, so now we completed. We can see the output similar to the other one. So it's the same output that HammerdDB will give it to you. So in this case, now we are putting the results on a variable called results2. So we can see, actually, let me spell it, it's result2. So similar to result1. So we have, in this case, the name of my test is now is E4, not E2. And for each virtual user, or each number of virtual users has a different set. So 10 and 5 and so on. So we can do the next text, or we can generate the spreadsheet to visualize, see how things are going. So we did result1 and result2. If we sum those two, do F8. So what I'm doing is just putting the two results together so I can pivot those. And again, I'll run my my pivot table definition. So for each column, it's going to do it. Run it. And then I'm going to generate, again, another Excel spreadsheet. So do F8. And that's it. So if we go to temp, there's a new one. But again, I don't have Excel installed on my VM, so I need to upload it to OneDrive here. And I'll upload this one and see what it shows. So now I have the two results. Remember, I concatenate two results, the E2s and the E4s, which each set of virtual users, 5, 10, 15, 20, and then I have the results here to see if they're better or worse. So we can try first the number of orders per minute, and then I have a side-by-side comparison of my first test and the second test. So the blue line is when I tested with 2 CPUs, and the orange line is when I tested with 4 CPUs. And as you can see, well, there is not much until the last bar here. when it was 20. So let's go back to IOPS. So F is my data drive. So and you can see they're all kind of limit to 3000, right? So even though I have 2 more CPUs, still not a big improvement. So maybe making the change on the size is probably wasn't the best one. So if we go back to the portal and let's make another change. So remember that we had E2 first, and the max IOPS is 3,750, right? But the E4, the max IOPS is 6,400. So even though that we increase the size of the VM, we are not close to 6,400, right? Still 3,000. So we are limited on something else. So let's look at the disk, for example. Here we have the disk. So this one, the max IOPS is 120. But if we look at the details here and go to size and performance, so you will see that the P4, which is the initial disk, the provision IOPS is 120, but it can have a burst of 3,500. So that's the reason that you can see in our chart here, the IOPS is close to 3,000. So we are limited right now by the disk. So let's say we change to a P30. So we are over allocating because our database is about 10 gig. So now we are going to have about 1 terabyte. So the provision IOPS is 5,000, and it doesn't have max burst. So we have to resize it. To resize it, we need to stop the VM. So let me go here. Okay. So overview, stop my VM. Yes, I want to stop it. So I'll take a few minutes until it stops. And then it will tell me when it stops. But then remember, we need to do one change at a time. So we already made, we changed the size of the VM. And then we are going to change the size of the disk. So for to make one change at a time, so I had to go back to the previous VM size. So since I'm over here, so remember we are using the E series. So it was the E4. So I'm gonna resize it to what it was before. So initially it was the E2. So I'm gonna go back to the initial size. So I'm gonna resize to 2 virtual CPUs, and then I'm gonna resize the disk. So I'm going to, over here, and then go to size and performance. So it was 32. Now we want 1 terabyte, so the P30. So I'm gonna resize this disk. Successful resize, and now what else? Oh yeah, we need to resize the other disk, which is the log disk, which is over here. Go to P30, resize. So it is being resized. And since we are here, remember I mentioned that here you can also see the performance counters on the portal, but I'm getting the performance counters from the VM, not from the portal. Since I'm getting the performance counters from the VM, I can also do the same for on-premise VMs. So the same code will run for on-premise. All right, so I already resized it. So let's start my VM again. Do the refresh, to start. So I'll take a few minutes to start. But then we can go back to our script, which is over here. So we go back to the test number 3. So here I name my test E2 because we went back from E4, right? So the previous was E4, P4, and now I'm going back to E2, but with P30 disk. Oops. E2 with P30 disk. So I'm gonna run this. And again, this is going to take about 4 minutes. So I'm gonna pause the recording. Okay, so now we completed our third test, and they're in the variable result 3. So we can, oops, result 3. We can see similar to result 1 and 2. Tells you, the name of the test and the virtual users, right, and the performance counters. So now we can concatenate all those 3 results together. So we can visualize all 3 on the same chart. And again, this is the definition for my pivot table. And then I'm gonna run the same thing here. So delete the file I already have. And generate it again. So I already have it here. And again, I don't have Excel in my VM. So I'm gonna upload it. I'll take a few minutes, 2 seconds. All right, so there are 3 tests now. So the first set is with 2 CPUs, the second with 4 CPUs, and the third one we went back to 2 CPUs, but we only changed the disk size. And we can see the number of orders per minute is improving, but again, it's better to visualize it. So go back to our graph here, and we can see the difference. So remember, the blue bar is when we have 2 CPUs, and then we change it to 4 CPUs just to see what happened. And there wasn't that much improvement because the bottleneck was on the disk. So here, the gray bar is when we are using 2 CPUs, but with a P30 disk. So we oversize, we make the disk about 1 terabyte, I think it was. So from 32, so we over allocate it, but we get better performance. So even though my database is only 10 gig, right? So if we go to the IOPS of F, all right, so the IOP of F is close to 5,000 over here, which it was the limit for the VM. Let's see, go back to the portal so we can check again the size. So the size was the E, right? So we went back to the E2. So even though it has a max IOPS of 3,000, the problem was because of the disk, right? So the disk. So before it was 32, so now is 1,024. So we can get 5,000 IOPS, which is what we got almost over here, right? So close to 5,000. So So you can see, with these tools, you can benchmark each change if you're, doing better or worse. And then with the Excel pivot chart, you can, analyze the results better. And then you can see other performance counters that we collect. The CPU also is over here. So yeah, we use more CPU because it has more data to insert. And then on the 4 CPUs, the CPU goes down because you have more cores or more virtual CPUs. But yeah, so this is the chart you will get to analyze your data and see what change that you make is making performance improvements or not. So let's go back to our PowerPoint slide. So this was our demo plan, right? So we did 3 changes, and for each change, we're going to change one thing, and then we collect the workload to see it was a change in performance or not. And so that was for the demo. And as you can see, it was easy to run. Just run the commandlets, so you can automate other things, or you can automate the changes, or you can use different VMs. Here I have the code on the script, but so I was making the changes manually, but you can insert with Azure PowerShell. You can also automate the change you want, or you can have different VMs already pre-allocated. But in this case, I did a change one at a time, so we can understand better what I did. And so that's the code. It's pretty easy to use, just the commandlets, to export Excel and to run SQL commands and so on. So now the next part of our presentation is to do a deep dive of the code. So as I mentioned, I did I used the Crescendo module to create a wrapper of the HammerdDB command. So for that, you will need PowerShell 7. And then you need to install the module, the PowerShell Crescendo module. And then the easy way to start is to modify one of the Crescendo samples that come with the module. So you just modify it, and then you just run your own. And then if you need to create a parsing function, you can. And then the next command that you run is the export Crescendo module, which is to generate the module. And once the module is already generated, you can deploy that module for PowerShell 5 or 7. So we run in both versions. So to author, you need PowerShell 7, but to run it, you can use PowerShell 5 or 7. So let's go back to our demo VM. Yeah, let's do a save for this one. So here on the conference materials, you will have all these scripts. So I already installed the Crescendo module. So if we go to Windows, users, I installed it in my account. So it's PowerShell modules. So this is a PowerShell Crescendo module. And it comes with a folder called samples. And here are the JSON files that you need to create a wrapper for an executable. And you can open any of those. For example, the first one. You can look at the documentation, but all you need to know on some of them is just the name of the executable. But then you can pass, so each tag means something. And there are other ones here, for example, for Docker or tar or who, right? So these commands, so it has a verb, noun, and so on. So I already created my own. So I copy one of those and I created mine, which is this one, Hammer DPS Crescendo, which has similar format, right? So it has my verb, is invoke, my noun, and the original name. So HammerdDB runs with this executable because it's a TCL script that it runs. So all I'm doing is passing the information, the examples, the name of the parameter, right? So there's a parameter called TCL script, an action. You remember on my demo when I created the database, invoke HDB CMD. So I had to pass the name of the TCL script, the action, authentication, database, and so on. So those are in here. So that's where you define all the parameters. So all the parameters are defined here, the examples, and then you need a parsing function, which I'll show you next. You put it as an output handler. So here it will parse the output, and once the output is parsed, it will convert it to PowerShell object. And once it's in a PowerShell object, you can manipulate it as a regular PowerShell. So the function that does the parsing is over here, and is called resolve HDB output. So what it does is for each line from the output, it's going to initialize some variables, and then it's going to parse each line. And the easy way to parse is to analyze the output and then look for patterns. In this case, I'm looking for the word test result. So here also I put an output of the run, for example, that has a test result. So here you'll see that it has all this output, right? But always it has a word called test result. So always at the end, it has a test result, and it's only one match, right? So it's pretty easy with this text because it's the only match. So that's what I'm going to do with PowerShell, is find the match. So if I go back to my export, so that's what it does. So let's say, and I can run it right now. So I'm going to load the function into memory. So I'm going to select it so we can see it. So I'm going to load it. And right now I'm going to read the output text, the file that I show. So I'm going to put it over here. So I put in the R variable, right? So if I do R, so it's the same text that we saw. And then if I pipe the function, it's going to parse it for me. And it's going to find the number of virtual users that this test is was made, and the number of orders per minute and the transactions per minute. And they all come from the output text. And then if you remember, the output text. Again, it is over here. So it's in line 122, right? So if I go here and I do R 122, oh, well, it shows blank because it's 0 base, so it's 121. So here I have the same line here. So I'm parsing this line. And then the next thing that I do on my function is to do a split. So I'm looking for the blank space. So now I have all the member or all the elements that were split by the blank space over here. So I can also go to a particular one. So in this case will be, let's see, start with 0, 1, 2, 3, 4, 5, 6. So it will be 6. So now I parse the number over here, which is the number of orders per minute. But I can parse the other ones. And that's what we got on the function here. So I'm parsing 6 and 9. All right, so the next one is 9, which is transactions per minute. And the virtual users, I look for virtual users created. And then if I find it, I get it. And those are the variables that I show here when I run it over there. So that's how it works, the parsing function. And then once you get the parsing function and the JSON file, right? So this one, the JSON file is to define the parameters and the executable name and all that. And then I'll define the name of my module, and then it will export it. So you run this, it will show up on the location I told them to go, which is over here. So those where the modules is, and then if you look, or we can look at how the module looks like, right? So this is auto-generated for you. So the Crescendo module did all this. So this is the output handler, or the function that I just showed. So you put it there. And then this is the function that I'm running. And there is a set of parameters, parameter sets, right? If you run the Windows authentication or SQL authentication. And that's it. So all this is auto-generated. So, and this is a synopsis, description, all from the JSON file. The help of the parameters and all that, and which are the same as if I run the a help file, right? If I do Control-C here, if I do help. So those are the ones that show up there, define it on the JSON file, right? Parameter, description, all that, and examples that I put there. And that's it. So that's pretty easy to generate a wrapper of an executable. So all you need to know is the name of the executable. So for HammerdDB, it's a little bit tricky because the name of the executable is the compiler for the TCL language, right? So they use a TCL. But that's it. So that's the way it generates the wrapper. So Special thanks to Microsoft for supporting the data platform gigs and SQL Server gigs and community initiatives. And also, there are 3 ways to win prizes, as shown here in the PowerPoint slide. And that's it for now, and hope you like it. And I'll stick around if you have any questions. Okay.